Hi students, now in this part we will be learning about the structural representation of any chemical molecule. We will see that there are condensed formula, there is wedge dash form formula, and there is a simple linear chain formula. So all these things we will learn in this structural representation of organic compounds. Here we proceed. So students, in this part we want to learn the structural representation of the organic compounds. So here we proceed. Now there are three things: complete, condensed and bond line structure formulas. Complete, condensed and bond line structure formulas. So the existence of the Lewis dot structure, which we have already studied in the chemical bonding chapter, they are now in a dash type or in a bond line type. Dash type or the bond line type, which I have written here. In the Lewis dot structure it was dot 1. And here you will see that I will be describing ethane, ethene, ethyne, these all molecules by a dash in between. By a dash in between. So your covalent bond is actually shown by a dash, which was earlier also I used to show. Similar representation here. Now this is your ethane, ethene, ethyne. Ethene, ethane and ethyne. And it is very amazed to see that they are they can rotate their bonds, right? We have already learned these are what? Sigma bonds. Ethane is what? It is your C2H6, right? Now in C2H6, all the bonds which are present are sigma bonds. So that's why here this can rotate, ethane can rotate like this. Ethene, on the other hand, ethene, it is what? It is your, a somewhat restriction is there. It is not that much free. And ethyne is not free. Ethyne is not free to move because of the 2 pi bonds there in the ethyne. So how do we represent? We represent by again this line concept, and those lines at the terminal end, if nothing is attached, we say that it is a methyl group. If hydrogen is attached, then it is already hydrogen. For example, if I look at this molecule, 3-methyl octane. So I can represent it in this way also. I can represent it in this way also. I can represent it in this way also. So these are like these all are the same compound. 3-methyl octane. Here also if you do the numbering, you will get the same thing. Here also if you do the numbering, you will get the same thing. Here also if you do the numbering, you will get the same thing. What makes the difference? Here I say that this is just like a normal formula or a bit extended model of the condensed formula. This one I have proper dash in between. And this one I don't even represent the CH3 or CH2 there. I already mean it. If it is a single one, that means I have a carbon present there, freely one, terminal one. If I have hydrogen there, then I will represent that H is present there. Otherwise it is a carbon. If I have 2 free there, then I will say it is a ethyl group present there. So terminals always mean that it is my methyl group present. One terminal if it is there. Similarly, you can represent 2-bromobutane. We can represent 2-bromobutane also. How? Like this way, and this way, in a similar way. Dash and the terminal formula. Dash and the terminal formula. What about the cyclic compounds, guys? If I just say cyclic compound, then I have bond line formulas like this. This is what? Cyclopropane. Cyclopropane. This is cyclopentane. Cyclopentane. This is cyclohexane. Cyclohexane. So when I'm saying cyclo means what? It will be a closed structure. It will be a closed structure. Like here you can see cyclopentane, cyclohexane, cyclopropane. So why cyclo? Because they are in a cycle. They are closed. Okay, they are closed. That's why I say they are the cyclic compounds. And this is how do I represent them. Okay. This here, one is solid line. Okay. This is a wedge line. The second one is little light, right? Wedge line. So we call it even the wedge and solid formula. Wedge and dash formula. Okay, wedge and dash formula we say, which I'll be introducing in the next part. So this is how I write my structural representation of the organic compounds. I hope it is clear to all of you. So students, in this part we saw that how do I represent any chemical molecule of organic compound as a form of condensed formula and Saw and Hodge formula and wedge and dash formula. Now in the next part I'll be telling you something about three-dimensional structure, which was here just like a planar structure. There I'll be dealing in the three-dimensional 3D geometry. Stay tuned with me for that.